Okay, start recording. So today we're going to do P3 chapter 2, logarithm and exponential function. Okay, for this topic I split into 5 parts. You will have an indices rule, logarithm rule, okay, E and natural log, graph and transformation, and linear law. Okay, so let's continue. So from P1 you already learned about the indices rule. Okay, let's do a recap. Okay, one, if I have a plus a plus a for k times, then I have a k times of a. Okay, you write as ka like this. So if I have a times a times a, with for the m times, there will a power m like this. For 3, if I have a m times by a n, we have a power by m plus n. Okay, in this way. 4, if I have a m divided by a n, I will have a m minus n. 5, if I have a m power by n, so I have a and n, or equals to a n power m. Number 6, if I have a power 0, it will have equals to 1. Number 7, a power 1 equals to a. Number 8, a power of negative n equals to 1 over a n. Number 9, a power of 1 over n is n root of a. Number 10, okay, a power n over n equals to n root of a n, or n root of a power by m. If I have 11, if I have a power m times by b power m, I have a b power m. And 12, I have a m divided by bm. I will have a over b, the whole thing power by m. Okay, as a recall. Okay, so number 1, number 2, okay, and number 9 will be considered as a definition. Okay, then for students who are going for higher tier university, you should learn about the proof or the reason why each of these rules are true. Okay, so this will be something that you're supposed to remember if you are going for a higher tier university. Okay, so next we go for the log rule. Okay, log rules. Let's of course, for some of you already so familiar with the rule. Okay, let's just do a recap for the rule. Okay, rule 0 says if a power x equals n, then log a n equals to x. Some students having difficulty to actually remember this. Okay, the rule to actually see whether they maybe the position of the a, x, and the n, they wrote it wrongly. Okay, in order to avoid that, okay, so there is a easy way to actually memorize it. So everybody know 10 square equals to 100. Okay, so when you write in the form of log, you'll see there's a O here, 0. Okay, there's a O there. Therefore, what you can do is you can write it as all the 0, all the one with the 0 you put on the same side, then equals to 2, the non-zero on the other side. Okay, so this and this will be interchangeable. So you can actually try to memorize by, instead of writing, memorize it in the form of AXN, you can actually memorize it as a 10 square power equals to 100. Then rule number 1. Okay, so if I have a log AB plus log AC, then I have log A bracket B and C together. If I log AB minus log AC, I will have a log B over C divide together B over C. If I have a log of BK, okay, the K is a power, then K can actually write in front. Number 4, if I log AA will be equals to 1. Number 5, log A1 equals to 0. Number 6, okay, log A of 1 over B, it can be written as negative or log AB. Number 7, log AB can be also written as a log CB over log CA by changing base. Number 8, log AB equals to 1 over log BA. Number 9, log A of AK will equals to K. And number 10, A power of log AK equals to K. Okay, so out of all, this one will be important when it comes to the upcoming topic, when it comes to the differentiation later. Okay, you will need to know how to actually apply this. Okay, so from here, from the 11 rules that we have here, the first one is the definition. Okay, then the rest you need to know how to actually prove them. Let's try to prove them one by one. Okay, so number 1, scroll down. Okay, so number 1, okay, log AB plus log AC equals to log of AB times C. Why is it true? Okay, so we let log AB equals to L, log AC equals to M, log ABC, okay, equals to N according to the indices rule. Okay, rule 0, the definition. So I have A power L equals to B. I have A power M equals to C. Then I have A power N equals to BC. Okay, with these three items together, you will see that from the line AN equals to BC, the AN, the B is A power L. The C is A power M. Again, according to the indices rule, we have A power L plus M. You will see that N is equals to L plus M. So therefore, the rule is true. Number 2, if I have a log AB minus log AC equals to log of AB over C. We try to do it similarly. Okay, so I let log AB equals to L, log AC equals to M, log of AB over C equals to N. According to rule 0, the definition, so I have A power L equals to B, I have A power M equals to C, I have A power N equals to B over C. According to the indices rule, okay, from the line, starting from the line AN equals to B over C, I have AN equals to A power L over A power M. Therefore, you will have AN equals to AL minus M. So because of division. Okay, therefore, N equals to L minus M. You can see the rule is true. Okay, number 3. Right in the red color. Number 3 is okay, BK. Okay, log of A BK. Okay, so B power K here means, okay, so you have a lot of B being times together, B times B times B, a lot of them times by B. According to rule 1, okay, according to rule 1 earlier, when two things are multiplied together, you can write in the form of plus. Therefore, over here, you can write it in the plus form. A log AB plus log AB plus log AB all the way to the last one log AB. Okay, so therefore from here, by counting how many B that you have, you will see that you have K times of log AB. So it's K times of log AB here. You can see the reason is the rule is true. Okay, number 4. Number 4 is okay, A1. Number 4 is okay. So from indices rule, okay, from indices rule, A power 1 equals to A. We know that this is true. Therefore, if we write it in the log form, I will have a log, okay, the A equals to 1. So you can see these two by definition. Number 5, okay, from A power of 0 equals to 1. So this one also tells you that log of A1 equals to 0. Okay, therefore you have seen that log of 1 always equals to 0. That's the reason. Okay, number 6. Number 6, we have log of a1 over b. Okay. Number 6, have log of a1 over b. Okay. According to the division rule, b over c you can write as log b minus log c, like this. Therefore, I can write this one as log of a1 minus log of ab. From rule number 5, log of a1 is 0. So 0 minus log of ab. Therefore, it's negative of log ab. You can see the rule is true. Number 7, okay, we are talking about the rule of the changing base. Okay, log of AB equals to log of CB over log of CA. Okay, let's look at the working. So I let log AB equals to L, log CB equals to M, log CA equals to N. According to the definition, I have A power L equals to B, I have C power M equals to B, I have C power N equals to A. Okay, so let's see what can we get here. So C, from the first line, A power L equals to B. Okay, and A is C power N, so Cn power L, and B is Cm, Cm here. According to the indices rule, I have Cnl equals to Cm. Since it's the same base, the power must be the same. So Nl equals to M. Okay, if you by writing L as a subject, you have M over N. You can see the rule is true. Okay. Number 8. Okay. Log of AB equals to 1 over log of BA. Okay. So from the line log of AB, if we do changing base, okay, into the form of BB, okay, log of BA like this, okay. So because of changing base, I can change to any base that I need. So I change it into the base B. Okay, according to rule 4, so log BB equals to 1. So it's 1. So we have a over log BA. So you can see the rule is true. Okay, number 9. Okay, log of AAK. Okay, so according to the rule number 3, okay, K can actually bring to the front. So log of AA, and log AA we also know is equals to 1. So it's equals to K. Number 10, log, not log, A power of log AK equals to K. Okay, so this one is a bit harder. For if let's say you are concerned about why is this rule is true, you can take out your calculator. Okay, you can try to key in any number. Okay, let's say base 8 then, for example, base 8 power of log 8. Okay, you can fill in any number here. Okay, it's always give you that number. You can actually try. Okay, so of course over here we're talking about the proof. Why is it so? So first of all, we let y equals to a log ak. Okay, so I'm going to log a both sides. Log a here, log a here. Okay, so you can see this is log ak is a power. So I put it in front. And log AA is 1. Therefore, you have log AY equals to log AK. Remove the log A and the log A, you see that YA is equals to K. You'll see that it is true, the rule. Okay. So therefore, they will be the 11 rules of the log rules. Okay. And after that, 3, you need to know what is E. Okay, what is E? E is an irrational number. Okay, that discovered from nature. Okay, so just like pi is also a number that they actually discovered from nature. So, and it's an irrational number. Irrational number means it cannot be written as a fraction. And if you press calculator, your E equals to 2.71828 something. Okay, for your information, the formal definition of E is actually limit of n goes to infinity 1 plus 1 over n power by n. We can actually observe it from the table here. Okay, so I have n, the value of n, I have the 1 plus 1 over n. Okay, so let me take out my calculator. Okay, replace with 1. So I have a value 2. Okay, I replace it with 2. I will have a value of 2.25. Okay, if I replace it with 10, I have 2.593744246. If I replace it with 100, I have 2.7048133829. Okay, if I replace it by 100,000, okay, so I have 2.718268237. You can see that the number here is getting nicer and nicer. So when you go to infinity, what you actually got is the E value. That actually gives you 2.718281828 at the back. So you can see that when the n value getting larger and larger, the value stop changing. Then this value is E. Okay. So what is EX? Okay. So Ex will be limit of n to the infinity 1 plus x over n power by n. So compared to what we have above, so you can see the 1 here change into x. The 1 here change into x. Okay. Next, why Ex important? Okay, so Ex is one of the 2 functions in the world that its differentiation equals to itself. In other words, if you ddx of Ex, it gives you Ex. Okay, so but here you also need to know the proof. Okay, the alternative form of it will be e power of fx. The fx you need to differentiate and put in front, and you copy the same thing efx here. So let's talk about the proof for this one first. Okay, the ddx of Ex equals to Ex. Let's scroll down. Okay, so now proof. We want to see, okay, ddx of Ex equals to Ex. Okay, so let's look at the working. So ddx of Ex, according to the definitions of Ex, we have limit of n goes to infinity. Okay, 1 plus x over n power by n. For information, the limit operation and the ddx can switch places. So I can write in the form of limit n to infinity here and the ddx here with 1 plus x over n power by n. So now I can actually differentiate this thing. Okay, limit of n goes to infinity. So I differentiate this, bring down the power minus by 1, multiply differentiate of the inside. So you can see the n and the n here got cancelled off. Limit of n goes to infinity, and 1 plus x over n powered by n minus 1. Okay, let's observe this carefully. You should able to see that this is looks similar with the definition. Okay, since n is go to infinity, n minus 1 can also go to infinity. Therefore, they are actually the same. Therefore, it is Ex itself. Okay, that will be the proof. Okay, next, you need to know. Okay, and the second reason that Ex is important, because we can find the number E in the real world. Okay, regardless in finance, biology, population, physics, radioactive, probability, computer science, economics, etc. You'll find the E at everywhere. Okay, so therefore this is the reason why you need to know how to actually do exponential and log. Okay, next, graph of Ex. Okay, you need to know how the Ex graph actually behave. Okay, E is a number in between of E is a number 2.71828 something. So it's in between of the 2 and 3. So by observing the shape of the graph, you can see that 2x, okay, will be the blue color. Okay, it's more flatter, and the higher the base, it will become more steeper. Okay, but all of them does not pass through the x-axis. Therefore, the range is greater than 0. You have a horizontal asymptote of y equals to 0. Natural log. Okay, so you will see in your syllabus, you will see something look like this lnx thing. Okay, lnx means log base e. Okay, log base e, loge can be simplified as ln. So from 0, 0, we know that ax equals to n. Okay, we written for log base a, n equals to x. Similarly, so ex equals to n, it can be written as ln, n equals to x. Okay, so the ln here is basically log. It's just a log in base e, that's all. Graph of lnx. Okay, please note that ex and the lnx, they are inverse of each other. Okay, you already learned inverse function from P1. So inverse here means you have a reflection at the line y equals to x. So if we look at the shape itself, so we have the line of y equals to x, we have the curve of ex. Under the reflections, you have the lnx graph. So over here, you will see the domain is greater than 0, the range is everything, and now you have the vertical asymptote of x equals to 0. If you want to compare with the different base, okay, ln again is a base e is a number 2.7 something, so you can see 2 is over here, the blue color, 3 is over here. Okay, next you'll need to know graph transformation. So continue from previous topic. Okay, you need to know how does the transformation works. Okay, this is your original graph. They will have some sort of transformation that you need to know how to do it here. So let's try to do the transformation. Okay, if I have ex plus 2, so it means that the whole graph shifted up by 2. So now this is 3, this is 2. Okay, if I have a e of x plus 2, it means that the whole graph will be shifted to the left by 2. Okay, so this point here now, this will be negative 2, 1. Okay, and this will be e squared. 2 of ex, okay, means it's a vertical stretching. So it goes like this. So this one goes to 2. E of 2x, e power of 2x means it's a horizontal compress. So it will go like this. Okay, by now you should be able to see that they are all revision from your P1 transformation. If I have a negative of ex, okay, So negative here means is a reflection by the x-axis. So the shape will go like this with a -1. And e power of negative x will be reflection by the y-axis. Then therefore the shape will actually go like this. Modulus of ex, the shape will remain the same because this one representing folding from the bottom. You have nothing for the bottom for you to fold. So therefore the shape remain the same. Okay, e power by modulus x. Okay, according to previous lessons, we say that we erase the left hand side, we copy and reflect the right hand side to the left hand side. Therefore, the shape is actually the red color part, the final answer. And e power by negative of modulus x, we say that we cancel the right hand side, we copy and reflect left hand side to right hand side. Therefore, I will have the shape that actually look like this. The red color is your result. Next, we go for the Ln graph. So what if I have a Ln plus 2? Okay, you can see the first two. I purposely bracket the Ln x and the x plus 2 so that you actually can see the difference. You during exam, if you're not clear which one is it, you should ask. You should raise your hand and ask. Okay, is it referring to this one or this one? Therefore, the bracket is important. When you write your working, the examiner, you cannot expect examiner actually understand what you're actually presenting. You need to show clearly the bracket. So what exactly is the transformation for the first one? Ln x plus 2. It means the whole graph shift up by 2 units. So you have 1, 2 here. Okay, and what if you have a Ln of x plus 2 like this inside the bracket? It means the whole graph shifted to the left by 2 units. So you have x equals to -2 now. Okay, and you have -1 here. Okay, then this is a ln 2. Okay, if you have a 2 of ln Ln x, okay, you have a vertical stretching. Let me draw it nicer. Okay, vertical stretching. If a ln of 2x, okay, you have a horizontal compress. So now this is a 0.5. Okay. If you have a negative of Ln x, so you have a reflection by the x-axis. You have a Ln of negative x, you have a reflection by the y-axis. You have a modulus of Ln x, you have a folding. The red color is the shape look like this. If you have a Ln of modulus x, so you have both sides. If you have a Ln of negative ln x, this one no graph, because you cannot log negative number. If you have Ln of x minus 2 inside the bracket, it will be shifting to the right by 2 units. So this will be 3, this will x equals to 2. If you have a Ln of x plus 2 modulus, like this, okay. So how to actually draw this graph? We might need some help. First of all, we need to draw the modulus x plus 2 graph, okay, to understand how does it work. So modulus x plus 2 graph will be look like this. Okay, you have a 2 here, you have a -2 here. This is a modulus of x plus 2. Okay, then the -2 will be your asymptotes. Okay, and you have the value, the graph look like this. You have two sides. This will be -3, this will be -1. Okay, this will be our Ln2. How do I get this -3 and -1 here? Okay, this -3, when you put it inside, -3 plus 2 become -1, modulus become 1, ln 1 becomes 0. So this is 0. Same goes for this -1. -1, if you put it inside, -1 plus 2 become 1. Okay, so Ln1 equals to 0. of course you do the reverse calculation. But over here, what we actually, what I want to tell you is you can use the blue line to help you get the shape done. Same goes for here, our end of modulus x plus 2. So modulus x plus 2 graph, okay, it will be like this. Okay, modulus x plus 2, so this is a 2. Okay, so the shape will go to here. So this will be ln2, like this. Okay, and if you have a ln of x minus 2, so I trying to draw this graph first. So x minus 2, so I have a 2 here, I have a 2 here. Okay, then my shape will actually go like this with the asymptotes, of course, with the asymptotes. So this is a 3, this is a 1. Okay, if I have a modulus x minus 2, okay, modulus x minus 2, the graph look like this. So I have a 2, I have a negative 2. Okay, remember we cannot log negative number, so nothing at the middle here. So this will be the asymptotes, this will be asymptotes, the shape will actually look like this. This will be a 3, this will be a negative 3. If I have a 2 minus modulus x, okay, the shape will actually go like this. Okay, this will be a 2, negative 2, this will be a 2. Okay, these 2 will be the asymptotes. Okay, by the way, this is a 2. These 2 will be the asymptotes. This time, this part that being negative, therefore no graph over there, the shape actually go like this. And this is minus 1. Of course, over here, you will need to learn how to actually do the graph transformation. In the event that the questions appear, you are expected to know how to draw. Each of these graph, you need to practice, okay, to settle each graph within 3 minutes. Therefore, you don't tell me that okay, this one is very easy. I go in the during the exam hall, then I do one by, then do the draw the graph one by one. Then already can already. Okay, so this is something that if let's say students didn't practice, they go into the exam hall, they definitely spend a lot of time. Even that they actually get the answer done, they already have no time for the other chapter already, other question already. Okay. So you need to practice to settle each of these graph within 3 minutes. There will be exercise here, okay, that you're expected to do, know how to do. Okay. Then over here, the exercises is no other than maybe involved with the graph, quadratic, simultaneous equation, okay, or maybe rearranging algebra. Okay, whatever that you need to know how to do by using whatever the rules above. Okay, and finally, the last part of the topic is called linear law. Okay, so for those students who actually done MS before, this one is actually quite familiar. The concept is to convert a non-linear curve into a straight line. Okay, to convert a non-linear curve into a straight line. So I have two cases here. One is in the form of y equals to ax power n. Okay, so example, let's say y equals to 2 or maybe 3x squared. So obviously, this is a quadratic graph. Okay, this is a curve. Remember our objective? Our objective is to convert nonlinear curve into straight line. Okay, but how do I actually do that? Therefore, from here, okay, I need to do some work. So maybe I do ln first. Ln x equals to ln of 3x squared. Then I apply the rule ln 3 plus ln of x squared. Then I will have a ln 3 plus 2 times of ln x. So you have ln y equals to 2 times ln x, okay, plus ln 3. So what we see from here is this is your capital Y, this is your capital M, this is your capital X, this is your capital C. So in the end, you will get the shape of the graph in the ln x, ln y, okay, that passes through the ln 3 here. Okay, this is type 1, case 1. Case 2. If I have a y equals to abx, okay, let's say I use an example of y equals to 2 times 3 power x. Okay, 2 times 3 power x, the original shape itself will be look like this. Okay, this is a 2. Okay, this is how the shape look like. If you're not sure, is this shape correct or not, you can actually go for decimals. You can try to key inside decimals to actually verify it if you are not sure. Okay, and this is your x, this is your y. Okay, this is your x, this is your y. Okay, so our purpose is to get the straight line. Okay, our purpose is to get the straight line in the straight line form. So over here, okay, I will do ln at y, I'll on both sides. Okay, 2 and 3 power x. Okay, then I have a ln 2 plus ln of 3 power x. X bring to the front, x of ln 3. So what I get is ln y equals to ln 3 of x plus ln 2. So how do we actually see it? Is we see this as my y, capital Y, this is my capital M, this is my capital X, and this is my capital C. Okay, so in the end, I actually get the shape that actually look like this, a straight line with intercept of ln2. Okay, so from here, okay, you need to answer the gradient questions, solving the equations, and so on accordingly. Okay, there will be exercises here that you can do. Okay, and the answer, okay, I put the answer underneath. Okay, and this is everything of P3, exponential, and log. Okay, stop recording.